In this lecture, I will quickly talk about rules for constructing integer, real and character constants. Let's get started with integers. Here are the rules for constructing an integer constant. An integer must have at least one digit. As it is an integer, that is whole number, it should not have a decimal point. Numbers like 1.1, 20.5 are not valid integer constant. It can either be positive or negative. If no sign precedes, it is assumed to be positive. No commas or blanks are allowed within an integer constant. These are the examples of valid integer constants. I will go to code blocks and create a C project. I will write a printf statement that will print an integer constant. Printf in double quotes %d, since I want to print integer constant, comma, I will try integer constant -34, ending the statement with semicolon. Here -34 is valid as it consists of only digits and preceded by negative sign. There are no commas and blank space in -34. Let's compile and run the code. The code works fine and we can see the output on the screen which displays integer constant -34. I will now try to create integer constant with space in it. I will replace -34 with 3 space 4. I will compile and run the code again. If you see here, the compiler displayed an error as it could not recognize the value 3 space 4. Let's talk about real constants. There are two forms of real constants in C: fractional form with decimal point in it and exponential form with mantissa and exponent part in it. We will talk more about it in upcoming slides. Following are the rules for constructing real constants in fractional form. A real constant must have at least one digit and have a decimal point. It can either be positive or negative. If no sign precedes, it is assumed to be positive. No commas or blanks are allowed within a real constant. These are the examples of valid real constants. Let's go to code blocks. I will type a printf statement to display real constant of float type. Printf in double quotes %f, since I want to print real constant of float type, comma, let's try to print 1.0, ending the statement with semicolon. I will compile and run the code. If you see the output screen, the printf statement displayed the real constant 1.0. I will now update this value to 0.3. Compile and run the code. This also worked fine because the rule says real constant should have at least one digit and one decimal point with no commas and blank space. 0.3 satisfies all the rules, hence it is a valid real constant. Now I will update 0.3 to just decimal point and try to compile and run the code. The code could not be compiled as it does not satisfy the first rule that says real constant should have at least one digit. What we learned just now was real constant in fractional form. There is one more way to construct real constant, that is exponential form. Before going through the rules for constructing real constant in exponential form, let's go through a couple of examples. Here is an example of real constant in exponential form, 3e4. 3e4 is equivalent to 3 into 10 raised to 4. Let's have a look at another example, 5e12, which is equivalent to 5 into 10 raised to 12. Here, 5, which appears before the letter E, is called mantissa part, and 12, which appears after letter E, is called exponent part. Now, let's go through the rules for constructing real constant in exponential form. Mantissa part and exponential part is mandatory and should be separated by the letter E. Mantissa part may have positive or negative sign. Default is positive. Mantissa part can be integer or real constant in fractional form. Exponent must be positive or negative integer. It can't be real constant in fractional form. For example, 3e4.5 is invalid since exponent part is not an integer value. Let's go to code blocks. I will type printf statement to display real constant with exponential form. Printf in double quotes \n %f, comma 3e2, ending the statement with semicolon. This value is a valid real constant of exponential form as it satisfies all the rules. It has got mantissa and exponent part separated by letter E, and exponent part is an integer. Let's compile and run the code. You should see this output on the screen. This is because 3e2 is equivalent to 3 into 10 raised to 2, which is 300. Since this form is a type of real constant, we see the output displayed with decimal point. Let's try one more thing. I will write another printf statement, printf in double quotes \n %f, 3e4.5, ending the statement with semicolon. I will compile and run the code again. If you see here, C compiler returned an error. This is because we are trying to use decimal value in exponent part. The rule says exponent part should be an integer. It cannot be a real constant. Let's move on to rules for constructing character constants in C. A character constant is an alphabet, a single digit, or a special symbol enclosed within single quotation. Maximum length of character constant can be 1 character. Let's go to code blocks. I will write one more printf statement to display character constant. Printf in double quotes \n %c, since I want to print character, I will print character A, ending the statement with semicolon. Let's compile and run the code. If you see here, this did not work because I did not enclose character within single quotation. As per the rule, it should be enclosed within single quotation. I will now enclose character A within single quotation and compile and run the code again. If you see here, character constant A is now displayed on the output screen. Let's summarize what you have learned in this lecture. An integer constant must have at least one digit and must not have a decimal point. A real constant in fractional form must have at least one digit and must have a decimal point. A real constant in exponential form must have anti-sign exponent part separated by letter E. If no sign precedes an integer or real constant, it is assumed to be positive. A character constant is an alphabet, a single digit, or a single special symbol enclosed within single quotation.